Okay, hello again, everyone. Now we have been talking about how we can solve quadratic equations. So far, we've seen how we can solve by factoring, as well as how we can solve by graphing. Okay, so our next method that we're going to talk about is what's called solving by undoing. But before we actually get there, I just want to talk about how we can simplify radicals, and in particular, how we can simplify square roots. Okay, so radical square root will be an example of a radical. So we'll focus on how we can simplify square roots, and this is a square root symbol. I'm sure you've seen this before, but just as a reminder, let's say I want to talk about the square root of, say, 4. Okay, so what that means is one number times itself will give us 4. Okay, in this case, that's pretty straightforward. That's just going to be 2. Okay, now you might say, well, -2 times -2 is also 4. So then why isn't the answer -2 as well? But for now, we're just interested in the positive square root. Okay, so whenever you see the square root of something, of a number, we're always going to take the positive root. Okay, so a few more examples. Let's say I have the square root of 9. One number times itself is 9. In this case, that's 3. And then so on. I can take the square root of 16 as well. That's going to be 4. And then so on. Okay, so now it gets a bit trickier if I ask you, let's say, what's the square root of 12? Okay, so one number times itself is 12. Okay, in this case, we see that there's no integer that when you multiply it by itself is 12. Okay, so it's not going to be a nice number like 3 or 4, right? And so in this case, we don't know how we can deal with the square root of 12. Now, we do know that it's going to be somewhere between 3 and 4, right? It's going to be 3 point something, because 12 is between 9 and 16. So then the square root of 12 has to be between 3 and 4. Okay, so we don't know exactly what that value is, but we do have a way to simplify square roots like these. Okay, and here's actually a nice little formula that will allow us to do that. So for example, if I have the square root of a times b, we can actually break apart the square root into the square root of a times the square root of b. Okay, so this is going to be very useful. It's going to help us simplify square roots like the square root of 12 when we don't know the exact value. Okay, so we'll use that to help us simplify. But before we actually get there, I just want to go ahead and kind of list out the perfect squares that we know. I'll do that right over here. So what perfect squares do we know? Okay, so perfect squares are numbers that we can take the square root of, right? So starting with 1, because square root of 1 is 1. Square root of 4, right? We did that over here with the square root of 4, 9 and 16. And 9, 16. And then what's next? Well, that's 1 times 1, 2 times 2, 3 times 3, 4 times 4. 5 times 5 will be 25. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. And of course, I can go on forever, but I'm going to stop at 100. Usually these are the ones that we should have memorized or can get pretty easily. Okay, so we'll use this list to help us simplify. Okay, so how do we simplify? Let's look at some examples. So let's say I want to find the square root of 8. Okay, again, this is not going to be an integer, right? Because 8 is not on our list over here. There's no integer multiplied by itself that will get us 8. Okay, but here's what you want to do. So whenever we're simplifying square roots, you want to find largest perfect square factor. I should say find D. Find the largest perfect square factor. Okay, so what you want to do is you want to go back up to this list, and I guess I shouldn't include 1, and you'll see why in a second. So I want to go back up to here to this list, and I want to find the largest number that can go into the number that I'm trying to simplify. Okay, so for example, if I had the square root of 8, okay, so I want to find the largest perfect square factor. So if I go back up to this list, what's the largest perfect square on this list that can go into 8 evenly? In this case, that's going to be 4. Okay, so what I can do is I can rewrite square root of 8 as the square root of 4 times 2, right? Because 4 times 2 is 8. And then I can use my formula up here that I highlighted, and I can actually break that apart into the square root of 4 times the square root of 2. Okay, now why did I do that? Because now the square root of 4, we know what that is, right? Because that is a perfect square, and that's just going to be 2. And then square root of 2, this we can't really simplify anymore, so we can just tag that on, 2 root 2. You can write 2 times root 2, but as a shortcut, we can ignore the multiplication symbol. Okay, so this is what we mean by simplify square roots. If you want to find the largest perfect square that can go into the number that we're interested in. Okay, now, of course, we can always use the number 1, right? Because 1 can go into any number, but then that wouldn't really help us simplify, which is why I didn't use 1, which is why I crossed out 1 up here. Okay, so let's do a few more examples. Let's say square root of 175. Again, I want to go back up to this list, find the largest perfect square that can go into 175. Okay, now it might help if you have a calculator handy, right? You can just kind of divide 175 by each of these numbers to see what's the largest that it can go in. So now if you try that, let's say you divide that by 4, divide that by 9, and so on, you'll see that 25 is actually going to be the largest one, right? Because then you'll have 25, and if you divide 175 by 25, you'll get 7. And then again, we can use our formula that we saw before, break that down into square root of 25 times square root of 7. And then square root of 25, we know what that is, that's 5. And then root 7 can really be simplified, right? Because there's no number up here that can go into 7 evenly, except 1, but 1 won't really help us. Okay, so there's that. And then let's just do a few more for practice. Square root of 48. Okay, once again, find the largest perfect square that can go into 48. Let's go back up to this list. So 48 is a much smaller number, so that should be easier to find. Now, the largest one is actually going to be 16. But let's say you didn't use 16, okay? Let's say you saw that, okay, 4 can go into 48. Let's say you use 4 instead. Okay, so let's see what's going to happen if we use 4, right? So that's going to be square root of 4 times square root of 12, because 4 times 12 is 48. And then square root of 4 is going to be 2, and then times square root of 12. Okay, but then notice that we didn't use the largest perfect square, right? The largest should have been 16, but we used 4, which also works. So then what's going to happen is at the end, you can actually keep simplifying the square root that you have left, right? So here, the square root of 12, you can actually simplify that a bit more, right? Because we can do 4 once again. We can break that down into square root of 4 times square root of 3. And then this is, again, that's 2, and then root 3. So really what I have is I have the 2 root 3, and then I have the 2 up here. Right, so then my answer is going to be 2 times 2 root 3, which is 4 root 3. Okay, so we will get the answer eventually, but you see that if we don't use the largest perfect square, right, you always want the largest perfect square, then there will be more steps that you have to do. Okay, so let's see what will happen if I use the largest perfect square. So square root of 48, if I use the largest perfect square, which we saw is 16, I can just do square root of 16 times 3, because 16 times 3 is 48. And now I can just jump to the answer, right, because that's 4, and that's root 3. So I do get the same answer either way, but the nice thing about finding the largest perfect square is it's going to save us a lot more time. Okay, all right, square root of 162. Again, that's a much larger number to find. So let's see what perfect square can go into it. Again, I think it's easiest if you use a calculator, especially for the larger numbers. In this case, we'll see that, or you'll see that it's going to be 81 is the largest. Okay, now 9 can go into 162 as well, right? Because 9 is also on this list. But again, 9 is not the largest perfect square. Okay, so 81 is, and square root of that is 9. And then I have square root of 2. And that's it, because square root 2 can be simplified. Okay, and now let's just do, a couple more with adding and subtracting. Okay, so let's say I have root 75 plus root 27. Now, here's what we don't want to do. Okay, now adding is different from multiplying. So when we're adding square root, we cannot just add up the 75 and 27 and say this is the square root of 102. Okay, that will not work. It only works for multiplication. So let me erase that. What you do want to do is you actually want to simplify each of these first. Okay, so square root of 75. Again, I want to find the largest perfect square on this list that can go into 75. In this case, I think it's going to be 25 again. 25 times 3 plus, and then same thing with the 27. Simplify that. What's the largest perfect square for that? I think it's going to be 9. And now what I can do is, well, first of all, let me simplify a bit more. So this is going to be 5 root 3 plus, and then over here, I think it's going to be 3 root 3. Okay, so with the radicals, it's kind of like combining like terms. Okay, so we can only add or subtract these when we have the same thing underneath the radical sign. Okay, so if I have root 3 and root 3, now I can add them. So 5 root 3 plus 3 root 3 is 8 root 3. Okay, it's like adding 5x and 3x. That'll be 8x. So same thing with the square root. We can only add those if we have the same thing underneath the square root sign. Those are going to be like terms. Okay, and then kind of last one for practice. Again, we can't just add or subtract these yet. Let's simplify first. 72, simplify that. What's the largest perfect square that can go into 72? Again, a bunch of these will work actually. 4, I think, will work. 9 will work. But you want the largest one. And in this case, I think it's going to be 36. And once again, please use your calculator to help you with these if you're not, or especially with the bigger numbers. 28, I think this time it's going to be 4 times 7, 4 being the largest perfect square. And then finally, 18, that one's not too bad. I think that one's going to be 9 and 2. Okay, so now let's go ahead and go to the next step. That's 6 root 2 plus square root of 4 square root of 7 is 2 root 7. And then minus, that looks like 3 root 2. Okay, so now we're ready to kind of combine like terms. Okay, so which ones are like terms? Well, I think it's going to be 6 root 2 and the minus 3 root 2. So if you combine those, we get 3 root 2 and then plus 2 root 7. And then there's nothing else we can do because that's root 2 and that's root 7. So those are not like terms as we talked about. Okay, so that's that. Again, this will help us next when we do what's called solving by undoing. But we will need to know how to simplify square roots before we get there. Okay, so again, the key thing is kind of knowing this list. Now, this list does go on and on, but you should know these up to 100. And again, you can always use a calculator to help you find the largest perfect square that can go into your number. Okay, as always, make sure you're taking notes and let me know if you have any questions. And then please go ahead and try the assignment for next time. And other than that, hope you have a great rest of your day.